Assalamualaikum warahmatullahi wabarakatuh. And good day to all panels. So my name is Syafiq Mohd Khairi. So today I'll be presenting about my project on design and development of motorcycle blind spot detection system. So for the introduction, based on the report by Road Safety Department of Malaysia, the total of vehicle in Malaysia are 30 million. That is, so 45% of the total of the vehicle are registered motorcycle. So Malaysia has the greatest rate of fatality on the rate of has the greatest rate of fatality on the highways, with more than 50% of the death of motorcycle per 100,000 in the Asian countries. So for the problem statement for this project, so most motorcycles are not well fitted with safety equipment such as airbags, crumple zone that can be found in a modern vehicle. So motorcycles are much more vulnerable to accidents besides car and other vehicles. So in most of motorcycles such as moped, the blind spot detection system is not yet implemented. The objective for this project is the first to develop a system that can detect a moving vehicle in the blind spot of the motorcycle. The second is the gear must be easy to install and can be used in any type of motorcycle, specifically moped type motorcycle, because Malaysia has uh, the greatest amount of moped users. And the third, to investigate the efficiency of the developed system. The scope on this project is to develop a system that can detect moving vehicle, and the gear must be easy to install, and experimenting on the developed system for its efficiency. So next we go to the methodology. So this is the system flowchart. So the system start, and the ultrasonic sensor will detect the obstacle. If the object is in the range of 200 cm, the LED will light up. So if the distance is over 200 cm, so it will end the system. So the LED will not the interface will not warn the rider. So if the distance in the range of 200 centimeter, it will warn the rider by light up the LED. So for this project design, so the hardware we use for this project is ultrasonic sensor, that is HCSR04, and Arduino Uno, and LED. So we use for the software, we use Arduino integrated development environment. So we use Arduino IDE to develop the program for the system. So for this project, after the product is fabricated, there are 3 experiments that have been run to test the efficiency of the product. So the first test is moving vehicle detection system, the detection test. So this test will put the ultrasonic sensor in static position, and then a moving vehicle will pass by in the range of 1.5 meter. So the distance between the ultrasonic sensor and the passing vehicle is 1.5 meter. So the vehicle will move at different speed from 20 km per hour to 50 km per hour. And then the second experiment is the comparison between the true sensor and sensor distance. So the true distance is the distance we measure by using measuring tape, and the sensor distance is the distance that have been coded in the program. So the sensor is put in static in one place, and then there is an object in front of the sensor. First, we edit the coding of the system. Let's say 20 centimeter. At 20 centimeter, it will detect the object. So the object will start at 20 centimeter, and then the object will be pulled slowly until the LED is off. So after the LED is off, we push it slowly to measure the true distance. In this case, we want to find the error on the sensor. And the third one is testing sensor sensitivity with different type of rain intensity. So in this experiment, the distance between the sensor and rain, the starting of the rain will be constant, and the variable is the different type of rain. So these are the results from the first. These are the results from the survey that I have collected from PSM1. So from this survey demographic, we can see that most of the survey is collected by men aged 18 to 25. So they are the major of this survey. And then I collected the count of license type, the license type that they have. So most of them have B2 class license. B2 is 250cc and below. So there are a few that has B1 and B full. Okay, next, this is the background study for accidents. So for the first, we can for the first graph, the left graph, the cause of accident. You can see that the top three, the cause of accident. So we can see that the majority of them have experience on accident when going in or out of an intersection. And after that, overtaking other vehicle and changing lane. So these three uh, causes have blind spot related accidents. And the second one is the what are they bike is how the participant prefer to look at the side mirror or move your how the how the participant prefer to look at the blind spot of their motorcycle. So if or they prefer to look at the side mirror or move their vision sidewards. So most of them prefer to look at the side mirror, and and half of them prefer to move their vision to look at the blind spot for a better angle. So these are preferred warning system. So there are various place at the motorcycle that we can put, and various sensor we can use. So from this for this survey, we survey is they want to use infrared or radar or ultrasonic. So most of them choose to use ultrasonic and put it at the rear left and right of the motorcycle. So it can detect better for the blind spot of the motorcycle. So the surveys also takes on the product specification that the participants preferred. So the most the most rated important for the product specification is range area covers. So it can be plug, waterproof, and brightness of blinking light. So after considering many hardware and so this is the system coding. So this is the system coding with the full system coding. So for the first part, so from the define and the float. So this part is we define the pin for the sensor and the Arduino board. So for the trigger pin and echo pin for the first sensor, we put at digital pin at 2 and 3 at Arduino. So trigger pin 2 and echo pin 2 is for the sensor number 2, So we put it at digital right 4 and 5. So for the second part is float. This float is where we declare the duration for each sensor and distance. So duration 1 is for sensor number 1 and duration 2 is for duration number 2. So for distance 1 is for sensor number 1 and distance 2 is for sensor number 2. So in the void setup, we're gonna set which pin is for output and which pin is for input. So in this setup, pin mode trigger pin 1 is for output. Trigger pin is where the ultrasonic sound will be emit, so it will be output, and the echo pin it will be input, where it will detect the reflected wave of the trigger pin. So and then pin mode number 7 and pin mode 6 is for the output for the LED warning interface. And serial begin is the baud rate of the data in the Arduino. And next part is the void loop of the system. So first, we must clear the trigger pin from any wave. So we set it as low, and then we delay for 5 microsecond. After that, after we delay 5 microsecond, we trigger the trigger pin and set as high, so it will emit the ultrasonic sound wave, and then delay for 10 seconds, and then we set it at we set it back low, so the ultrasonic sensor will be triggered by 10 microsecond. And then after it after that, we it come for the calculation for the duration. So duration is equal to pulse in. Pulse in is when the echo pin is echo pin high. So uh, when echo pin receive the reflected ultrasonic sound wave. So and then for the distance is duration. The first equation, duration is times by 0.0343, that is sound speed, and divided by 2. So that is the calculation in this system. And the last part is the condition. So if the distance is be in the range of 200 cm, so digital right 6 high. So for distance 1 is for LED number 6. So when it detect the obstacle in 200 cm, in range of 200 cm, so the digital right, so the pin for 6 is high, so the 6 pin is for other LED, so it will light up. So S is where for different condition, so it for over 200 cm. So when the obstacle is over 200 cm, so it will be low, so the LED will not light up. So it goes the same for the second sensor. We just edit the trigger pin and the distance. So next is the experimental result. So for this experiment, I have run 3 experiments. So for the first one is the sensitivity of the sensor with different mode of range. So in this experiment, the distance between the sensor and the start of the range is 50 cm. So the each for each range we run the test for 3 times, and each test we run for 10 seconds. So in 10 seconds, we the data taken is how much the light flickers in 10 seconds. So this is the average graph for the data. So in light rain, the LED light flickers in for 3 times in 10 seconds. and then it goes up for the medium, and then for the heavy it get worse in 12 flickers in 10 seconds. So we can see that in heavy rain the sensor will not work pretty well. It can still detect an object, but it will disrupt the disrupt the wave from the sensor. And then for the second experiment, this is the true distance and the sensor distance. From this experiment, we uh, from the experiment, I want to search for the error of the sensor. So this is the error. So when 20 at 20 cm, the error is 0.5, and then until 50 cm, the error is go up. So from this graph, we can see that the error of the sensor is increased when the distance increase. So when the distance of the obstacle increase, it will the error of the sensor also increase. For next, the moving vehicle detection experiment. So in this experiment, uh, the, this is data. So we this experiment is to determine the detection of the sensor for different speed of vehicle. So the different speed is 20. We use is 20, 30, 40, and 50 kilometer per hour. So the for each speed, we run it 3 times. So as we can see from the data, the system can detect up to 50 kilometer per hour. So it the speed. So this experiment concludes that the sensor can detect up to 50 kilometer per hour, so it can be used and the vehicle is moving. So for the conclusion, the motorcycle blind spot detection system has been developed successfully. So the system can run successfully and can be used. And also, this system can be also implemented in automotive, such as in car or big trucks that have bigger blind spot. So it will be safer for them when they want to drive, such as big truck. Big truck has bigger blind spot. And then for the third one, the ultrasonic sensor is not suitable to be used in heavy rain. So for further study, we can experiment more on how to improve the ultrasonic sensor to be used in heavy rain. So that's all. Thank you from me. Thanks for your time watching the video. Thank you.